All right, you are good to go, Jessica.
Cool. Yep, so Postgres Autovacuum tuning lessons from the field because I'm in the field. Right now I work for Enterprise DB. I'm in title the managing consultant for North America, the professional services team. Don't let that fool you. My hands are on a keyboard 99.9% of my time. My team is very independent. So things got very interesting around auto vacuum tuning, especially last year as we as a team got crazy busy. And I learned a lot the hard way. And I like to share the things that I learned the hard way so that fewer people have to replicate my painful lessons learned. So here's what I've learned. On some of my slides, I do have this icon. This means that there is stuff that there's extra information in my speaker notes. Sometimes it's just the written version of links that maybe I've hyperlinked. Sometimes it's extra quotes from documentation or extra resources, period. If I don't have time to call them out, but I think I will. We've got an hour, but this session isn't as time restricted as normally when I'm giving this presentation. So if you get through this and you still need help, the Postgres community Slack channel, if you're not familiar with it, that's a great place to collect all sorts of information or to answer questions for other people. There's also a Discord server. I don't know how much of the core development community is in there. That's a slightly less official group, but it's very active and slightly larger, I think. But as we go through this, definitely feel free to pause and ask questions as we go, or pause me, not pause you. Okay, so if you tap into those, get through this, you're still confused, tap into the Slack and Discord servers and you still need more help. I am a consultant, but I think last time I presented this, I was not actively working for EDB, and I am, so you would have to deal with their sales department, which is kind of, I'm sorry, but maybe if it's a smaller help thing, just reach out to me, not through EDB. Okay, so I'm glad we did introductions. I think this presentation is appropriate for everybody here. This is my standard, like, is this even, are you wasting your time by sitting in on this presentation? Although, you know, anybody's always welcome. It's just gonna be boring if it's not quite right for you. This is very much targeted towards Postgres beginners. Although there is some deeper information in there, but I left it in and have left it in because I find it very helpful to understanding, you know, the big picture with the auto vacuum. If your database has a lot of transactions or is a very large, well, and or is a very large database, meaning you have 500 gigabyte plus tables, this is probably for you. Auto vacuum is probably maybe not an issue exactly, but you could benefit from looking at it a little bit. The other big thing is if you suddenly are getting reports of slow queries that consistently or not consistently get slower and slower and slower over time, you probably have an auto vacuum issue. So this is also probably for you. Another symptom of auto vacuum issues that I regularly see, and it is very hard to convince people that they need to focus on tuning the auto vacuum when they see this, is unexplainable wall buildup. There are multiple reasons. Auto vacuum is not the only cause for that, but it is a symptom, as well as replication slowdown, which again, auto vacuum isn't the only thing that could cause that, but when it does, and you're focusing on replication tuning or archiving, you know, manually clearing out your walls, you're ignoring the root of the problem. So you should, if you can't identify another root cause, you should look at the auto vacuum. Not for you, this presentation, if you're purely an application developer who specifically just needs code changes to tune to make things faster, this probably isn't for you. That's a lot deeper actually. But but that's also implying that your Autovacuum is running fine and you just need a code change. This presentation is also not for you if your database is 9.5 or older. You need other help. And there are quite a few Autovacuum monitoring features and just general headaches that you need at least 9.6, but 9.6 is going to be end of life soon. So just upgrade. I know, standard advice, but it I mean it. And that's in the wrong place. So here I've got my Twitter handle at the bottom of every slide, but my email is in the speaker notes on this one if you do so need more help. So the reason Autovacuum exists is because, and most of you had experience with other database platforms, this is a difference. This is a major difference with Postgres. The concurrency control. Postgres uses multiversion concurrency control, and I'm shocked that I said that right, because that's a tongue twister for me. So what does this have to do with Autovacuum? Let's talk about MVCC first. When you've got multiple, you don't want your users' requests or transactions to conflict with each other. This is a way of enforcing, data integrity and constraints. So what multi-version concurrency control offers is transaction isolation. You want to lock for reads, but the general strategy here is not to lock for writes. And the way that Postgres does this, let's go back actually. No, we're good. Right off the bat, with having just said that, right off the bat, common question that I get is, okay, well, in the name, multi-version concurrency control, this implies that Postgres is keeping multiple copies of itself. So isn't my database going to be way huger? How do I calculate database size and how do I accommodate that growth if I'm constantly creating a new version with every transaction? The short answer is that's not really what's going on. There's a little bit of magic that if you get into the Postgres core code becomes pretty clear, but it's a headache and a half to understand. So just remember that note, that's not quite the way it works. The other things to watch out for here are, so keeping in mind that we're going to call it a multiple, another version. And in a minute, we're going to talk about why that's not entirely the truth, but for simplicity, we're going to refer to it that way. So when you run a transaction, let's say you update a row, somebody else comes in, updates that same row. The original row does not get deleted. There's another version of that row. The antiquated, the old version, that spot in the files at the physical level is going to be flagged as not for use for the database users. Now what that does, what we refer to that spot in the file in the Postgres community, that's bloat. Fascinating, very creative name. So the other question along, following the thread of the multi-version concurrency control is if there's heavy bloat, meaning if I have a table that has a lot of updates on the same rows and it's suddenly bloated because not very much of that, that's occupying space is actually going to be visible to my end users, is my disk space requirement going to, logically it feels like it should, but the answer is no, it does to a point, but this is where the Autovacuum helps us out. The Autovacuum comes in and it'll flag those for reuse, which we'll talk about. If your Autovacuum is not aggressive enough, this could lead to a large performance hit later, mostly because there's going to be less data found in cache and your the Postgres database is going to have to search more and more and more. You don't want that to happen. So this is where the Autovacuum is our friend. It's a magical, I love this comic. When I first had to start dealing with Autovacuum, it truly felt like some weird magic. I really didn't understand what it was going. So this comic really hit home for me because when the Autovacuum works, it's a beautiful thing. You hardly even notice that anything is going on unless you're really looking, or you catch the database doing something, usually off hours if you're logged in at midnight for something and you see the process is running. Oh, what is Autovacuum? When it needs help, that's when things get painful. So plugging back into the concurrency control and the multi-versioning, the Autovacuum is not magic. It's basically your local neighborhood garbage collector. And I like that analogy because I don't have a trash can. I have to actually walk my stuff out to a dumpster. But if you live in an area where you've got a little trash can that you push out to the curb, you're not buying a new trash can every week. You're reusing that. And that's essentially what the Autovacuum is doing. It's clearing it out, saying, hey, you can reuse this now. Kind of tricky. We'll talk about this because you're always going to have, it's essentially going to leave a watermark if you're calculating your database size, and you're never going, even if your Autovacuum has run successfully, you're never going to physically see that disk space available again. It's always going to look like it's in use. But, and we'll talk about this, not necessarily the case. So we need to understand files, blocks, and memory. Postgres, if you're brand new to Postgres stores its data files in 1 GB, or its WAL files, sorry. Those are WAL files are 80 megabyte chunks. So your data files are going to be 1 GB, and then your blocks are 8K blocks. Now within each of these blocks, and buffer cache, that's not good from another. Okay, so you're using the rows in these blocks. They're going in and out of buffer cache, and this is where if you have a lot of these blocks in here that you're not necessarily going to be using because they're, it's bloat essentially, your buffer cache isn't going to be as efficient because it's, a lot of extra problems there. So in those files, there is a header, and this is why Autovacuum looks like magic, but it is not necessarily. And this is also why it's not like having 2 or 3 literal copies of your database. There's essentially a map for the database attached to each of those blocks in the head. And in that map, it marks, it'll mark that block with the, the updated row, and it'll say, hey, this one is X old, X updates old. This one should no longer be visible to the user. Use that other one over there. And it essentially creates a map of which blocks to actually access and to hit to retrieve or update, the most current and usable data. So the Autovacuum, what it does is it goes through and so with this map can only be so big. I've got to backtrack here for 1 second. This map can only be so big. Once your transaction IDs hit and you look it up, but you see this number and you think that's huge, I'm never going to hit it. Yes, I've seen a lot of databases hit it because their Autovacuum wasn't aggressive enough, or they were killing it before it could finish, so it just wasn't running. Please don't do that. Please just let it run. And the map wasn't getting updated. And they were expecting, we'll just add an extra map. No, that's not how it works. It has to be updated. And the Autovacuum goes through and it does that. And it says, hey, this is actually not what that is anymore. So, don't use that for this, but hey, you can use it for this now. That only happens if you actually take advantage of the auto vacuum. Okay, so how do you know that the auto vacuum is doing its job? There are a few ways to go about this. You can use monitoring tools. You can run your own queries, which is what I had to do the last major auto vacuum tuning project that I had. The database was 9.5. So traditional monitoring tools were not picking up anything helpful around the auto vacuum. All sorts of monitoring alarms were going off for this customer. They had users that couldn't access tables. They had users that were trying to update things while the auto vacuum was running. They were getting frustrated because they were getting old data back. There were just a lot of things going on. And because traditional monitoring tools aren't, they're mostly designed to take advantage of the newer 9.6 and above extensions and views with Postgres. I couldn't use any of the traditional stuff out there. I had to come up with my own queries, my own, that's also painful. But it is the other way to monitor. I don't recommend it. I recommend using something. I do work for EDB, so our Postgres Enterprise.
I think we just lost Jessica for a second. She was having some internet problems earlier, so let's see if she comes back in just a second.
Okay.
Or maybe on her other account. While she's trying to reconnect, any other monitoring tools out there that people use as well that they normally like or like to see? We use Prometheus and Grafana to do all of our work. So Prometheus pulls the stats down into everything, and then we use Grafana to basically chart it out and show those charts and that sort of thing. That's kind of our method of doing it. Does anybody use any third-party ones that they do out there?
We had Datadog for a while.
Datadog's good, definitely. They've got some great things out there too as well. Yeah, I think.
I just wanted to ask Mike, how was your experience with Datadog? Because that's what we're going to end up having to use.
I guess our company shrunk a little bit, so we actually had to make some cuts, and unfortunately, Datadog was one of them. But it's a dream to work with once you get it going and running. And the company I worked at before actually had a shootout for similar things, and Datadog came out on top there as well.
Oh my gosh.
Are you back? I think she's still having some internet problems. A lot of lag. What I'll mention too on Datadog.
Oh, my internet just completely.
Okay, you back?
Maybe, I don't know.
You're consistent right now, so that's good.
Okay.
Yeah. Go ahead and share again. We were just talking monitoring tools since you're on a monitoring slide. What I'll mention on Datadog too is I always give them high props because the conferences and things that I've been to when I've seen a presentation from somebody with Datadog or one of the people of Datadog, they always just teach you something. They don't show Datadog really until the end. I love to watch their presentations. They're very well versed. They know what they're talking about and they teach you something regardless of whether you use their product or not. And
that's awesome.
Yeah, I agree.
So any company that does that is always high in my books because if you just come into a presentation and all you're doing is selling your presentation, that's a marketing presentation. It's not a technical one. But
Yeah.
Datadog does a really good job of not doing that. So another option. Okay, go ahead. We never stopped the recording, so feel free to keep going.
Oh, let's hope my internet holds out because.
Because we don't want
Anyways.
me to entertain anybody. So let's keep going.
All right, so what do you need to monitor? What should you be looking at? I'm currently running Autovacuum processes. That's complicated. That can be complicated to catch, because usually Autovacuum runs at night in the off hours. At least that's what you want. So if you have to catch it in the act, if you can't use some sort of logging tool and log analysis to do a post, and if it's bad enough that you have to catch it in the act, take lots of coffee with you. It's going to be a long night, but if that's what's going on, you're going to want to know. You're going to want a list of the Autovacuum threads in use. Most environments that I see allow for 8. I really wouldn't. I would say be careful if you're set up to run more than 8 Autovacuum processes. You probably could do something differently. And there also are memory performance hits with running more than 8, even running 8 period. It depends on what's going on. But so the other thing you want to know is your max auto vacuums. Again, 8 is typically the limit there. Disk writes and efficiency. So if we go back to when we were talking about the files and the blocks. Autovacuum, when it cleans this up, your walls have to be aware of this, your write-ahead logs. So you're gonna see heavy wall expansion and disk writes. So you're gonna wanna keep an eye on that as well. The last auto vacuum time per table, as well as your table bloat percentages. There are a few queries out there. You should just keep them handy, because without that, it's hard to know, okay, do I need to make auto vacuum more aggressive, or is it working as it's configured to? And this is, per memory resources and IO performance patterns and all of that. Maybe you don't want to increase the aggression levels on the auto vacuum. Maybe you want to consider doing something else architecturally. Like we've had some where we've split tables, or flat out had customers delete. We had this one, they were lovely. This kind of goes back to a code change. If you can avoid in any way repeatedly and unnecessarily updating the same row 1,000 times in one night, if you can hit it with 2 or 3 updates on that same row, you should do it. You don't need to be updating the same row, 100 times per hour usually. Usually you can do something a little differently. Your auto vacuum configuration in general, you just take a high look at those parameters in your PostgreSQL conf. You also want to look at your disk IO time and your CPU usage, which can get a little confusing, because especially if you've got streaming replication on or something else, those are going to look a lot worse than, don't entirely blame the auto vacuum. So you do want some historical information. You want to know how long the auto vacuum ran. So you are going to need to look at the database logs. You want to know how many times it ran per table. So if you've got a table that the auto vacuum is running for 6 to 8 hours on it every single night, got a problem. You also want to look at the frozen tuple age. Tuple is just your row age and your transaction ID consumption. If you've got a high consumption rate, that means you're updating that row over and over and over and over again. Therefore, auto vacuum has to do its job over and over and over again. It's like having your 2-year-old and giving them Cheerios and they dump the Cheerios on the floor and you have to clean that up, or the dog's gonna get it. And your 2-year-old is still hungry, so you give them another bowl of Cheerios and they think it's funny. This hasn't happened to me, if you can't tell. You also want to watch out for long-running transactions. Long-running transactions, period, can be their own adventure, but you're going to want to especially take note of the ones that are happening during your auto vacuum period on the table that auto vacuum is running against. Important detail, easy to forget if you're troubleshooting this in the middle of the night. Okay, so I mentioned the IO impact. What the heck was I talking about? So auto vacuum works off of, it calculates IO points, and this is what it's looking at. It's looking at your vacuum cost page hit, which is your cost of vacuuming a buffer that was in cache. So when your block is in cache, but that row has been, a row that lives in that block has been updated, and you have to, auto vacuum has to do its job there. That's a page hit that costs a little bit. Not a whole lot. The default there is 1. But I have a typo on this. Vacuum cost page miss. That's the opposite of that. So excuse my typo in the explanation. Should be cost of vacuuming a buffer that was not in cache. That is more expensive. That's 10 IO points. And then vacuuming cost page dirty. That's if it has to actually go in and modify a buffer that was in the buffer cache. That's 20 points. So definitely want to stay away from that. How do you control this? You set the auto vacuum cost limit. This, I have a note in here, and I say that this parameter is global across all your vacuum processes in your database cluster, but that's true if you're new to Postgres. That's true for your cluster configuration in general. Anything in the PostgreSQL conf, that's your whole cluster. What the cost limit does is this says, okay, this is how many IO points we're going to allow before we tell the auto vacuum to engage in a delay period before it tries again on this table. Very, very, very helpful because you don't want it to trigger right after it finishes if you've got a really big job or on a big table that needs to happen. Or if you kill it, again, you don't want it to immediately trigger before you put in place some other stop gaps. The auto vacuum cost delay. This is how long will we wait before my wording here, before the auto vacuum will strike again. As well as I've called out the vacuum cost delay and the vacuum cost limit because those parameters do exist, but if you haven't figured this out by the name of auto vacuum is the vacuum processes that kick off. I don't want to say by themselves because it's not really by themselves, but without human intervention, aside from configuring things up front, vacuum is something that manually you have to say, vacuum this table, please. If you can avoid vacuuming, you really should. That's going to lock your whole table, whereas an auto vacuum process is not necessarily going to lock your whole table, but if it's stuck on a row or a set of rows, your users are not going to be able to update that. So memory, we talked about IO. Now we need to figure out the memory side of this. The maintenance work mem parameter, that's going to be how much, among other things, how much memory can the auto vacuum use. So if you see that your auto vacuum is responsible for a certain amount of your CPU spikes, adjust your maintenance work mem. But keep in mind that this parameter is inclusive of maintenance operations beyond the auto vacuum. So that can be another thing to look for, though, if your backups are running or something else is going on while the auto vacuum needs memory and you're bumping up against the upper limits of that, look at your server and make sure you can do it first, but increasing maintenance work memory may help you. If you want to set a cap specifically on the auto vacuum memory so that your things like your backups and et cetera are not impacted as much, then you will want to look at the auto vacuum work mem parameter, but that defaults to your maintenance work mem max. So you shouldn't have to go out of your way. If you're okay with that, leave it. But if you have identified cause to change it, you're going to want to change it. So row freezing, this term isn't as scary as it sounds. It goes back to the map idea. As in Postgres, until it's auto vacuums, doesn't really, that row still exists there. But if it's the older one that the users won't see, that's referred to as a frozen row. And so something else that you could do if you look at your auto vacuum freeze min age, and again, there's auto is in parentheses on this slide because there is this parameter. I think most of these parameters exist for the vacuum processes as well. But the default on this is 200 million. What does that mean? That's the age of the transaction ID. I'm sorry, brain blanked there. Again, doesn't sound like a lot, but if you've got a database with heavy transactions, you're going to get there pretty fast. Your maximum allowed on this is 1 billion. Your auto vacuum is working, you're not going to hit that, but if you need to set the thresholds higher so that auto vacuum is more aggressive, you would raise that above 2 million. You just can't raise it above 1 billion. You've got other problems if you think you need to. So the other helpful thing is the auto vacuum freeze table age. And this, I would lean into this parameter a little bit quicker and more eagerly than I would the previous one. The default on your max freeze table age, freeze table, I said that wrong, but that's okay. This is going to be 80 to 90% of the auto vacuum max freeze age, but this is table wide. So this is how long can this table's oldest trend, or how old can this table's oldest transaction ID before we trigger an aggressive vacuum, which will read every single block. So you absolutely will see more walls generated, which will absolutely slow down any replication you have going on. And it will not stop until every block in that table has been read and possibly written. So careful with that one. Did I go backwards, or is this a duplicate? Oh, I should actually move this. So my recommendation typically on going back to the auto vacuum max freeze age, I'm not sure why I have this out here instead of back there. Your max freeze age, this is good information too that I forgot to mention. Your memory overhead is only 250 megabytes above what it is for the default max freeze age. And this freeze max age silently limits the vacuum or the auto vacuum freeze min age to half of this. So if you don't double check that, your min age, if you think your min age is less than half of your, either more or less than half of your max it, you've got another thing coming. This is going to override that. So how do we put this all together? Got an actual problem, figure it out. A table needs to be vacuumed if the number of dead tuples, so rows that are not going to be seen by the user because they are no longer relevant for whatever updated reason. when that number exceeds this threshold, and this is the formula for how you calculate it, then Autovacuum is going to kick in. The very, 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 very first things before you even actually go and start messing with the, look at the other parameters, but before you start messing with them, these are what I would look at: the Autovacuum vacuum scale factor and the Autovacuum analyze threshold. And definitely double check the documentation on those, but this is the general formula for how these play into each other. Vacuum base threshold times vacuum scale factor times the tuple, so the rows in your table. And it looks like I've shorthanded, so threshold equals, and that's your analyze threshold. More often than not, I've seen things can be worked out with code rewrites, but often it's too late, or people don't want to rewrite the code, and a lot of times management will support that decision to not rewrite the code and figure out things from the database side. So when you're having those discussions, you do want to set some threshold for, okay, how much bloat can we tolerate? And the parameters and looking at things through the database logs and the historical information is going to help you present a case, because running with zero bloat is not realistic. It's not going to happen, and it's frankly unnecessary. But you do want to kind of have an idea of the base of levels of your database performance, and then you want to look at if you suspect you have an auto vacuum problem as you're tuning. You want to continue, comparing your general performance and setting a threshold so that okay, maybe it's not perfect or ideal, but it's never going to be. Here's where we can draw the line so that we're not impacting, business operations. If you want to be more aggressive after you calculate that, raise your auto vacuum cost limit, lower the cost delay, and lower the scale factor. But again, keep an eye on it and keep your bloat tolerance in mind, because it's never going to be zero or even close, and kind of silly to set that as a goal. Be careful when adding new indexes. Indexes can be a good thing, but your auto vacuum needs to run on those as well. So if your indexes are constantly being updated, your auto vacuum is going to have to work harder to keep up with that, and that could be a point of contention when we're trying to reverse troubleshoot of why your performance against a certain table is slow. Well, maybe auto vacuum is struggling with the indexes. Definitely take advantage of maintenance windows. Take advantage of table partitioning. This is an approach that I've definitely taken with a few larger tables. It doesn't necessarily totally solve the problem, but users might feel the impact a little bit less. And then again, of course, can you look at the code? And I'm not talking about the Postgres code, I'm talking about your application code. If you can, do. And like I said, another thing to look at is excessive wall generation. If you know the kind of the normal wall generation rates, and you're regularly exceeding that, and your team is saying, hey, no, just clean up the walls, archive more aggressively. We had one incident where there was a lot of pressure to actually manually remove wall files. Don't do that. It was an auto vacuum issue. We went and we found that there had been 7 auto vacuum processes running for 5 to 7 hours, and they were not anywhere near done. And we didn't know what to do about the walls. And there wasn't really a whole lot we could do. We had to kind of just wait it out. But you want to be careful with that because your wall disk space, you know, if you hit that upper limit, you're going to have a lot of other problems, and you're going to wish that you would have taken some preventative action on your auto vacuum. But that is a lot to take in. Are there any questions? My chat disappeared, so I don't know.
The one I'd ask on this, just on the successive wall generation right here is, how do you kind of benchmark your wall generation? In other words, you know, what do you look at to say, this is what it normally is, this is excessive? You know, what are your two markers that you kind of use for that?
Yeah, so I have a formula, I have a script for that somewhere. I just time it within a 5-minute period where I know that, I mean, I do a benchmark of the database performance first, find a few of the busiest periods within I usually look at it for about a week if I can, and find a couple of days where it's particularly busy, or a few hours, depends on the application and the database type. But I narrow in on those busy periods, and I grab maybe like 5, sometimes 15 minutes, depending on how sometimes their archive is set. I'll match that, but usually I just look at 5 minutes, and I literally just calculate the space, and I say, okay, this is the normal range for a busy period. And if we're exceeding that while auto vacuum is running at night, it's auto vacuum related.
Yeah.
If not, then okay, we've got multiple issues maybe.
Okay. Good.
Jessica, could you go over that calculation again, or I don't know if it's maybe more in the presentation notes with the 0.2 and the 0.5, and I kind of was not keeping up with where to plug everything in. Here, yes.
Yep. Yeah. I forget exactly what the scale factor there. I can look it up actually in the documentation, because I haven't looked at that in a while specifically. I don't think I have any extra speaker notes on this one. Okay. Yeah, so the scale factor, that's percent of the table size. So if you've got your dead tuples is 20% or more of your, well, it's going to kick on at 20% of your table size. That's one trigger. And then
Right.
the analyze threshold. I really should stick that in the notes. Okay, so that's the manual override. Instead of counting it, I'm not sure why I have 5 here though. Instead of counting as a percentage, it's like literal dead tuple number. So I lied when I said that I had shortened the analyze threshold. Okay, so this, the reason that I actually included the formula instead of just saying, you know, adjust these two, is because it's auto vacuum isn't triggered by one or the other of those. It's those combined. So that minimum number of rows, and I think mine is 5 here because I probably pulled this out of a lab database that I have on my personal machine. So I want the auto vacuum to be really aggressive in that case. And because it makes math easier in presentations, if I've got 5 dead tuples in there plus 5 plus 20%, so it's never going to be 20% exactly. It's always going to be that plus 5 literal ones times the total number. That's what the first level of triggers for auto vacuum is going to be. Why did I set this to 5? I hope that was my database.
Default.
No worries, no worries. Thank you.
Great. Well, it's not one that I usually go in and change after like default deployments. So now I'm like,
Some point in the past, you had a good reason for it.
Right, I did. And I wish I would have made a note on this because now I'm, presentation gold. Why did I do that? Why is that there?
Okay, well, do we have any other questions? Nope, I guess
Yeah,
not.
will you be sharing the slides on the meetup site or?
So I'm gonna post the whole recording. Jessica, if you've got the slides somewhere and you want to share them, you can put it in a comment on the meetup as well.
Okay, I'll do that.
Because
great.
it is good to just to share the slides, but the recording, as soon as Zoom's done processing and I get it up to YouTube, I'll put a link in that same meetup group and say, here's the recording link, and it'll be up there.
Cool.
So for right now, I'm going to stop the recording.